I'm starting to record at the same time. So Carolina or Manuel, I don't know who will take the lead.
Manuel will take the lead.
Yeah, I think I can go. So I'll try to cover all that we have in an hour. Don't hesitate to stop me while I'm presenting with any question. I think it's better if we do them while I'm presenting than at the end, because it's a pretty dense in terms of how many things we're going to present. If you can, when you ask a question, just tell me what your role is, so I can try to direct the answer in terms of if you're a developer or more someone managing the solution or a librarian. Depending on your role, maybe the answer can be adapted better. So we are too many just to do a roundtable right now to see, to know each of you. So we'll pass that one. I'm just going to present myself. I'm the research and development director at My Science Work. So I basically look at all the technical aspects of our products and the implementation also. So let's go through. I've prepared a small presentation. I'm gonna actually juggle between the presentation and our demo platform, so we can actually see things actually. When I explain them, we will then go into the demo, so you can see how things work in there. Let me just share my screen first. Do you see my screen?
Yes.
Yes, perfect.
Good. So as I say, we're going to go through the architecture of Polaris OS. So basically, all the technical components, how they interact, and how they present themselves into the installation. Then into the main concepts on how we configure. We're not gonna have the time to go over all of them, but the three most important ones at least. And then some things that I will not be able to show you in the current demo platform, because those are things we have just developed and we have not yet merged into the GitHub code. But just for you to have an idea of what is the path that we are taking with Polaris OS in terms of developments. So for the architecture, what we have is a pretty simple one. Standard 3 levels where we have the storage at the bottom, then all the business logic and the presentation layer. The storage is composed of two components, one for all the metadata and the data itself, also the configuration data of the system, and then one component to manage all the documents themselves. Basically, when we are talking about the publication management system, this will be mostly the PDF that we put into the system, so they can be retrieved later by different people. The business logic is basically where all the processing happens. It exposes itself with a REST API that is used by the presentation layer, but can also be used by any other external application to interact with Polaris OS. Now, in each of these, what we have in the business logic, I'm just starting by the core of the system. It's built on Node.js. So you may already know what Node.js is. It's a JavaScript runtime designed initially to run scalable network applications. And it's based on Chromium V8 initially from Google. It's becoming one of the most important in terms of performance systems or development frameworks that we can use. As we develop on Node.js, we follow, let's say, the standard philosophy behind that, which is to expose everything on REST APIs. So we do have all the operations that we do in Polaris OS are exposed on REST API, which is secured, but can also be open. It depends on what you want to do. And one of the advantages we have with using Node.js is that most of the integrations we do actually come with something already done by someone, because there's a huge set of libraries already available in npm.js that we can reuse. Most of them are if not all, open source. So you can reuse them as long as you just follow the license that they set for each of them. Then we have the database, and I said the storage level. It's basically I say divided in two: one for the metadata and the data itself, and another for document store. So this is basically the metadata. This is where we store all the metadata for a publication, for example. But it's also where we store the users of the systems, or the configuration of the system, or the forms that we can present. So we do all that into one single database which is Elasticsearch. This is a NoSQL database initially made for logs analysis, but that has been grown now for almost any kind of application. And one of the main advantage of Elasticsearch is it's built for search performance. Basically, you can search almost in any way through multiple indexes at the same time, through only one. You can search partially. There are a lot of analyzers that you can actually implement to do those search. So we decided to use just one single database, being Elasticsearch, that one, to reduce the complexity of the final system. You'll see many applications actually use Elasticsearch as search index, and then they have in many cases another database to store data. It could actually be a NoSQL or an SQL basic or relational one. We decided to put everything in just one because the system is already complex, and then we didn't want to add another layer of complexity by adding an additional database. So everything is in there: configuration and data. Then we go to the document store, and the document stores, as I said, is where we store all the PDF and documents themselves. We selected here to use MinIO, which is a high-performance object storage system. It has an interface actually that is the same that AWS S3, so it actually allows to switch between one and the other easily. It also provides, we don't use them, but it also provides some connectors to present other data stores as S3 interface data stores, so you can handle them all with the same interface. In here, we use a standard, let's say, interface of MinIO with just 2 or 3 buckets, depending on the installation, to store all the documents. Now, what this means for Polaris OS is that we don't actually have to take care of where the files are stored, or how they are stored, or if there are too many for one single directory. It's all done by MinIO. We just have the document stored there, so we just put an object and retrieve an object through a REST interface. It is a secure one. That there's password and users in between, but we don't have to take care of all the let's say operating system storage of the files. And more than that, if we want to have a highly tolerant system, we could configure MinIO also to have geographical distribution capabilities. So it could always, if we say so, for example, have copies of documents in different geographical locations to ensure that if we lose one location, we won't lose the documents that are stored there, as in let's say in a standard database. It's an open source software, and as any software today, they also have paid instances that they administer themselves. But we install these directly in Polaris OS, or when we install Polaris OS, to allow the mean, the local usage of all of this. And then finally, we have the presentation layer, where we have decided to use Vue.js. Now, many people ask us why Vue.js and not Angular or React, and the answer is pretty simple in terms of how we made the decision at the beginning, which is at a point where we had Angular going from Angular 1 to Angular 2 and saying all their developers, you have to trash all the Angular 1 developments because they are not compatible with Angular 2. So we say, well, it is a risk if they continue to do that. So not sure we want to take that path. Then at the time, Facebook and React were, Facebook was deciding or tried to decide to say, React is not going to be completely open source anymore. You'll have to basically give all the ownership of everything you do to Facebook, and then they can do whatever they want with it. From the day they said that to the day they stepped back, some weeks happened, and those were the weeks where the decisions of the front-end applications were being made for Polaris OS. So we say, well, this is a risk. We don't know what's going to happen there. Too many people just taking the risk. Facebook is a big one, hard to fight with. So let's keep away from that as well. And that's why we choose Vue.js at the moment. It was a small one at that time, but it has grown a little bit, and it has come one of the three big players today, to the point that we talk, I would say, more today about Vue.js than about Angular in many of the communities. So that's why we decided to use Vue over the other two. Technically, it has become a pretty handful tool or framework to use. On top of that, we use Bulma and Vueify actually to manage all the styles, the styling and CSS, and to make that configurable. And then Vueify, it's a set of components that are pre-built, and that allows us to actually to develop a little bit faster in terms of what we present and how we present things. Now, in Polaris OS, there's, on top of those two, Bulma and Vueify, we have developed our own components as well to speed up the implementation and the development of the pages. So things like having a table with a search box included in it, it's something we have added by combining some of the Vueify components with the logic of Polaris OS, and that allows us to have, let's say, small search pages relatively fast. So to give us it's an overview of all the components, and now the next question is, well, how do we deploy that? We basically use Docker today to deploy every layer we have. In a production system, what you see in the screen is what we have for each, let's say, each container. So we are going to have one image of Elasticsearch, and that image can be used. Normally, we say at least there's at least 3 instances of Elasticsearch to ensure all the data is well kept and managed. We have 1 or 2 instances of Minio, it depends on each installation, and then on top of that, we can have normally we have 2, maybe 3. It depends on the workload we expect of Polaris OS. And it's in the same container where we have the business logic, which is the, let's say, Node.js application, and from where we serve the Vue application. Vue is going to be executed on the client side, not on our servers, because it's a client technology. But the application itself, it's actually in the same container than the backend application. Then on top of that, we can put a load balancer. Normally we use Nginx, mean, all of these we're using the open source and open versions. Even if most of them actually have paid versions, we keep with the open ones. And that's basically the deployment, let's say, picture of Polaris OS. In our own systems, we use a lot of Docker Swarm to actually let the orchestrator, which is Swarm in this case, to decide where the containers are going to be placed, and that allows also to easily upgrade or downgrade the number of containers for each of the layers. But that's not mandatory. We can have just a small standard installation where we say, well, we have 2 containers of these ones and 1 for this one, and that's it. So we do that just internally in our own installations when we develop and we test, because it's just easier when we have 2, 3, 4 clients at the same time, and we have to let's say use a set of servers for all of them. So that's the overall view of the technologies we use in Polaris OS. Any questions up to here?
I have one question about Minio.
Yeah.
I see that there is a community that is freely available, but I see also that there is a standard and enterprise version. All the functionalities that you are using are in the community version.
Yes, exactly. The same for Elasticsearch. If you look at Elasticsearch, you're going to find the same situation where they have the community version. Well, in Elasticsearch, a little bit more complex. They have the community version, the free version, and then the enterprise or the platinum first, and then the enterprise. We use the community versions each time for all of them. If you go to Nginx, you're going to find also there is Nginx and Nginx Plus, being Plus the paid version. We use the community or the open one. Does that answer your question?
Yes, thank you. Any questions from anybody else at the moment? Okay.
Okay, let's continue now. What I want to show you is basically the main concepts of Polaris OS in terms of, I mean, from the configuration or development point of view. I think you have already seen the user side of Polaris OS, where you can, how you do to deposit a publication, how you validate one, and all that. Now, for all that to happen, someone has actually to configure all that into the system. And there's 3 main concepts that I want you to, that I want to share with you today, so you understand what the flexibility behind Polaris OS can be. Now, the first one is an entity, and we can see an entity as, if we do the parallelism with a database, it's basically, let's say, a table in a database. But it's more an entity in an entity relationship model, actually, if you want to go farther than that. Knowing that we use a NoSQL database, we don't have actually the restrictions or the characteristics of a relational database. So we have, it's the main data objects, so we are going to see things like a publication or a research project or things like that as an entity. You could look at that as a table or a collection of data. Behind the scene is actually an index in Elasticsearch. There's a direct relationship between an entity in Polaris OS and an index in Elasticsearch that we create. Once you create an entity in Polaris OS, you get all the standard create, read, update, and delete operations available for that entity, and they're going to be available on the backend, but as well on the API. Just by creating the entity and defining itself. As I said, being a NoSQL database, you can have multiple type of data within the same record in database, meaning that you can have, for example, multiple objects within the same record. And we use these in Polaris OS also, for example, to store the predefined list of values. For example, you want to know, imagine you have different type of publications and you have a list of 5, 6, 7 type of publications. We're going to have normally an entity storing that, so that can be used then in the drop-down field to show all the options for a type of publication in this example. Now, some examples of entities, as I was saying before, about publications, where you're going to have all the metadata of the publication, including also what we call the normalized data. And I'm going to keep that concept of the normalization for a little bit later, when we're going to go into pipelines for you to see what that means, and how we actually take advantage of that in Polaris OS. It could be, for example, also researchers, where we have all the personal information. It could be a list of countries for a predefined list. It could be all the research projects or a list of data sets, for example. And these are just examples of what that could be. So let me go to, I think it's going to be, let's go to, now to Polaris OS, I'm going to go to the entities, and I just prepared a very simple one, so I can actually show you the whole chain of actions that we do when we want to define something. So here we're in the backend interface of Polaris OS, the administration one. Actually, normally you have seen all this one where you have the user interface, and then you can go to the admin section, and when you go to admin, you'll get exactly to where I am. So I just prepared all my pages here to make it faster. And in here we have then the entities as one of the let's say sections we can work with. Normally you have here the list of entities. I just made a small one, and from here you can view the content, you can modify the entity, you can copy it just to work in another one, and you can delete it. So the first thing I wanted to show you is just what the structure of this entity is. And I said, well, I just said this is going to be a list of people where I have the first name, the last name, the institution, or the affiliation the person is related to, the date of the last update, then the full name. There's going to be just the concatenation of the name and the last name, and then something again that I'm going to keep for later, which is the normalization and the institutions. So in here, you're actually defining what the structure of your entity is, and you can add fields, remove them as you want. Well, you can add them, remove them. It's going to be a little bit harder, because to remove something in Elasticsearch, you will have to go into all the data and remove the field into the data. But you can add the fields, and then you have basically many types of fields that you can use. And you can see, as I use here, for example, the type objects, where you can have a sub-objects within the object itself. And you can have as many levels as you wish. That's not going to be a problem. And then for each field, you can have some different things like, well, can we index using it? Can we sort using this field? Are we going to use autocomplete autocomplete normally to search when you are typing, for example? When you do all these, you have directly then the mapping that is done for you, basically, and it's going to be declared in Elasticsearch. But you could also just go and see the mapping directly as it is done in Elasticsearch. If you want, if you are a more advanced user and you want to directly see here or add here some fields. So in here, when you're going to create an entity, you say, well, this is the structure of my entity. Once you define the structure, you're going to click on create instead of modify, and your entity is going to be created.
Manuel,
yes.
I have a question about this. So you have the freedom to create entities, but how do you relate that to formats, to standards, to metadata formats?
To standard like Dublin Core, for example?
Or mods or more linked data approach, serif, something like that?
Yeah, it's actually up to you to declare the structure you want. There's no limitations. So all those models, what they define is basically the list of fields and relationships between the entities. So nothing actually, there's no restriction to tell you, you need to use, for example, name of publication as the field for the title of a publication. You can declare here whatever you want. So there's no restriction. We have used this system actually for publications, but I've used the same system for research projects or for, let's say, a list of job descriptions and people related to that. So it's up to your own definition, actually.
You build it up yourself. It's not a question of, for example, integrating something from schema.org in it. You're building it up and you map it to that.
Exactly. Yeah. Yeah.
Okay.
Yeah. Now, once you do that, I said before, well, you're going to have standard create, read, delete, and update operations through the API and directly in Polaris. So I'm just going to go, even if I'm just doing a little bit, advancing myself on the subjects. In here, I just click on the look at the content of the entity. So I have, well, in this case, there's only one, but I just created that yesterday for this presentation. But from here, I could modify this one. I could create a new one if I want. Let's say Carolina. Well, let's say she's as well. Makes sense work. And you see it's already created, or we could copy. You can use that. We call this using a model. So if you have a big entity and you want to copy some things that you change a little bit of it, you can click there to copy, and then you have everything. But what is going to be created is actually a new entry, right? Or you could delete if you want. To click a little bit faster than me, but yeah, here we go. So you have all the standard, let's say, CRUD operations. I'm gonna leave the API for later if we have the time, because it's a little bit more technical. But I do have some demonstration on how we can see the API. So this is basically what an entity is and how we create them. Now the next point is, so I'm gonna come back here, is the forms. So we have entities, but now we need to actually fill that data with something. And to fill those entities with some data, we need to have forms to let people know what they need to enter. Now, I said I was advancing myself a little bit when I showed you the content of an entity, because what you saw at the bottom of the entity, where I actually enter data and create a new record, is a form. So a form is basically a list of fields and formats that we want to present to a user, so that user can enter data. Or we could use also forms to display data if we put them on read-only mode, for example. We can configure them with multiple type of fields. We can have, let's say, standard entry fields like text, data, or dates or numbers. You could also have drop-downs, and you saw a little bit one of that when in the list of institutions that I was selecting my sense work from. You could also have the fields of type file drop, where a user can just drag and drop a file, for example, because he's just depositing a new publication and you want to get a PDF from there. It could handle long list of values through the API. You could say, well, if I have, let's say, all the researchers as one of my Dropbox, and I have thousands of researchers, you don't want to upload them all when you load the page. You want them to be loaded as the user types. So we can do that with REST APIs that are going to be called from the single page application to the backend, and then things are going to be retrieved as the user types. So that's a bit of optimization in there, and we can even embed some subforms into the forms. And this can be done for multiple reasons. One could be just to organize things better, but another one could be, imagine in the page it was right now, the institution wasn't there, and I wanted to add the institution. We could actually also do this type of operation of creating something in another entity while we're in the form of the let's say here the test entity. Example of forms, we have the deposit forms for any type of entity. We have the workflow validation, which is basically the forms that are going to allow you to say, well, I reject or I approve a specific action into the workflow. And then the one I used actually, which was the entity creation and update in the back office, the one that was just below the table that I was showing you. So let's go and see a little bit of forms now. So let's just go back here. What I was saying is here, what do you see here that says add an entity? So this part, this is basically a form that has 3 fields. It has the name, the last name, and the institution. This is a text field. The last name is also a text field, and the institution is a list of values, which actually comes from another entity as a list of values. So how do we create this? If we go back to the entities, let me just search my entity. You're going to see here that I say there's a form called test MGU. I'm not very creative, so I called everything the same: the entity, the form, the pipeline. So, but it's actually a different object. So it's a form called test MGU. That's the one that we're using here actually to capture the data. So if we go on to the forms, which is this menu in here, and go to test MGU, we have here then a form that is called test MGU that has 3 fields: the name, the last name, and the institutions. Now, these fields, these names that you see here, are the names of the fields in the entity, where the data is going to be entered in the form is going to be stored. So for name and last name, they're just simple text fields. We can define here things like what's the label that's going to be shown, if we want to have a help or not. And if we have a help, this is basically what is shown. Let me just go back here. What is shown in here? So this is this type of help. The label is basically this one. So what we use just to name the field. So what I was saying, the first 2, name and last name, are basically text fields. So they're not very sexy. But if we go to institutions, actually, it's what we call a select field. Now, select field is a drop-down where we say, well, this comes from the institution index or the institution entity. What we're going to display is the name, and what we want to store in the database is the ID of that name. So we're actually not storing the name of the institution, but we're storing the ID of the institution. And you're going to say, well, yeah, but what we saw there was the name, not the ID. Well, this is because if we go back here and really, again, go to test MGU, and we see in the back office what we show, because we don't actually need to show, sorry, I need to edit that. We don't actually show all fields. We show the fields we want when we configure the entity. And we say the last one is going to be not really institution, but someone that we call denormalization institutions, which is something I told you, well, we're going to see later what that is. So we're just saying here that what comes into the field, sorry, in here is the ID of the institution, and that goes into the institutions field. So if I actually say here, let's say, show me institutions, and well, I'm gonna call institution ID. And now I see my entity. Well, this is actually what is being stored in there. So something that's not very very readable, but it's internal IDs that we use. Now, how do we get to there? And this actually, well, let me just show you one thing before that. Sorry, which is I told you we could put we can embed forms into another forms. In some cases, to create new entities. So I say, well, one example is I don't have the institution, so I want to add that institution. So I kind of prepared this a little bit before, and I said I'm gonna use the API with another form that is called the institution form, and I'm gonna allow the user to, let's say, add an institution if it wasn't there. So now I have here, let's say, a link that say I can't find the institution. I would like to add it. Now that's a text that we can configure as we want. But basically, what that does is, well, that will open the form, another form in here, and that would allow the user to add the institution and select that immediately instead of going to another page and then coming back. So this is one of the use cases of embedding forms. But another use case would be just in terms of organization, you want to separate in different sections, and you want to have things like this, open and close type of objects. So you do that by doing a subform and then setting that as a specific type that will allow you to open and close. So what I wanted to show you just basically here is how flexible this can be by configuration. Now, it's advanced configuration. It's not every user that can do this. It's mostly administrators and people with some technical knowledge on how things would work, but it's configuration, basically. So let's now come back to this mystery here in terms of denormalization and institution. And to that, I'm going to go to the third concept, which is the pipelines. Now, what's a pipeline? A pipeline is a change of functions, that can be executed when a record comes into a database, or when a record is modified into a database. We actually define what we want. What we can do here is create default values, for example, that are not asked to the user. We can format some data. We can add new data. And we can also validate data types and mandatory fields. Now, how can this be used? Some examples. So the first one I put in here was the normalization. In NoSQL database, actually, we try to have all data into the same record for search and analysis purposes. So it means that, for example, if you say I have a publication, and that publication is published by some researchers, you're going to have more than the ID of the researchers in the publications. You're going to have maybe their names and last names, into the publication itself. So you can easily search by researcher in the publication entity. So to do this, we have created a function that we call denormalization. Now, denormalization is a wide concept. It's not created by Mansa's work, but the implementation in Polaris says this. And what we do here, and in the example I showed you before, we were taking the institution, and you saw that what we put in the field is the ID of the institution. With the denormalization function, what we are doing is going into the institution's index, taking a value that we want from there. In this case, was the name, and putting that into the test MGU record. So in that ensures us that we have that information in there, and they can use that for display purposes and search purposes easily later. So this is a concept that goes against all normalization concepts that we have seen into standard databases or standard relational databases that goes onto, up to third normal form and everything. In here, we're a little bit on the opposite, saying, well, we can do a little bit different because in some cases it's better for the implementation. Some other cases we can, other examples of pipelines we can use is, for example, the last update. We can have just a standard function that update a date into the database or into the record every time it is changed. So we have a trace of how that was done. Or we can define also a default value, for example, to define a counter as 0 and then count how many times something is updated or something like that. Now, in our example, let's go to our example here, and I go to pipelines. So I should have a SMU pipeline as well. Yeah, it is there. Now, what do we have here? We have first a generic complete, a function that we call generic complete to actually create the full name. Now, if you see in here, we never ask for the full name into the in the form, but we do have a field that is built with the last name and the first name, and this is done actually by this option. This say you're going to concatenate object name and object last. The name and the last name of the object coming in, and you're going to put that into the field called full name. So this is a handlebar implementation. We use a library that's called handlebar that allows us actually to work a little bit with objects. You can do conditionals, you can do concatenations, you can create dates. There are many things you can do. Now the second one, it's the last update. So this example of using, again, if you go back to the entity, you see that there's a date here. There was a date of, the last update. We don't ask for that date, but that date is actually put by this function into the record. Again, this is a handlebar syntax where we say, well, we have a moment is a specific library that takes the actually the date of the current day. And then the final one is the denormalization one, where we say, well, we're going to put in denormalization institutions. What are we going to put there? Well, we're going to go to the institution entity, and we're going to take the name. And it's implicitly here, what they're saying is what we have in the entry field is the ID of the entity of the record. So Polaris knows that here we're going to take the ID from this field in the form, and it's going to go to this entity to search that ID and get the name and put that into the normalization institutions. And that's how we end up to having here the name of the institution. And then you can do that with many things. If you're having a country or as I say, researchers or anything else, you can actually put all that data back into your main record, so you can then easily search or aggregate or do whatever you want with that. So that closes up the pipelines and the main concepts of Polaris. Just a small, yeah.
So now, I'm wondering a bit. In the end, you have a very flexible way of creating, in the end, a database format, the forms, and also authority systems. But how do you relate it to standards in the end? I mean, you have worked out a publication repository, a data repository, and a quiz in a bit. So, but in the end, you have to relate that to the different standards. It can be MODS, it can be serif for a quiz system. That's something I don't. Is it something that has to be built up internally to have a good plan to build it up, or is it something that has to be done later, the mapping?
No, that's something that I think you should do at the beginning, because you should say, well, I'm going to start with, you're going to pick up a standard in that case, and then in the conception and creation of the entities, you're going to define how that standard is going to map to the entities you want. So the entities are going to be defined basically by that standard in that case. So it's something that we need to do at the beginning, and to be sure that at the end you can map everything as you want. And
you did that already for the tools you worked out. You did it for the publication. Is that based on a model, or is it based on mods or on serif at the moment, or is it?
Maybe I can answer this one, Manuel.
Yeah,
just to give maybe more insight and detail. So because it's very important to understand the philosophy of the tool. Standards is one thing, and of course it's important for interoperability to map everything and to be sure that we can respect some standards. But within now the system, and we are working with different institutions, different disciplines, different countries around the world. And so what we noticed is that everybody started to talk to us about standards like Dublin Core for publication, like serif for the CRIS system. But everybody also has some specificity. And now more and more we are talking about maybe FAIR principles. I don't know if you are aware and familiar with this concept of findability, accessibility, interoperability, reusability, and FAIR principles gone beyond the standards that we know. And so Polaris OS has been think in that kind of philosophy. It's to say that we have some standards, we can know them, we can take the structure of Dublin Core, the structure of serif, but also we can be flexible and adapt every needs, because you don't have the same one if you are talking with an university with multidisciplinary fields, or a one just in humanities, social sciences, or one with health. And so we can really, build and after eventually map all the fields to be interoperable with other systems. But we can build not from scratch, but we can build from what we define before starting to implement the project. I don't know if I'm clear with that.
No, but that's in fact my question. As I understand, it's very flexible, but you start from zero at the moment. But you say we are not starting from zero. Huh? You have already, in the end, with your experience, built some basic entities, or is it basic entities related to formats, or to? Is it correct, or?
Yeah, we have actually. All the projects we work on, we start from a basic structure of publications and researchers. But as Jan said, then that takes always a different path, because they all want to add their own drop. But yeah, you can start with something that exists and then adapt from there. It depends on each kind. We have some that each implementation. We have some people that wants to start from zero, some that wants to start from something done. Both are possible. There's nothing. If you take the demo system that we have and the standard installation, that is going to give you a first definition of a publication, a repository, an institution repository with a publication and researcher and structure for everything. But it's an example. It's there. That could be a starting point for that, which is one that was mapped at some point to Dublin Core, but that has more fields than Dublin Core.
Yes, I can imagine that. Also, you need more flexibility. Surely, that's one of the problems of the. But I think with the entities, you can go very far. Really, that's true. Yeah,
that's right, and that's why I said we have used this. We have used Polaris OS for for institutional repositories, which is the first use case it was created for. But then it has been extended and used, and is used today for other implementations, like a research project with the same base, or for something that has nothing to do with this historical or history research, in terms of people that participate in a specific event or things like that. So it's more a repository of people and descriptions. And it's just because the flexibility allows you to do that, as you have well pointed out. So I'm going to go first to the recent development because we're running out of time, I think. And then if I have the time, I'll show you a little bit of the API. So the recent developments, why I wanted to show you this is because when you're going to take the standard application that we have in GitHub today, you're not going to see all of this because some has already been put into the repository, but some things are being finished and tested and are not yet merged into the public repository. So you may see a standard workflow, meaning you can define actions and states, and basically you define a transition states system where you say, well, which are my states and who can change from one state to another. And that's the basic workflow that the first version of the workflow that we developed. But now we have one that allows you also to do some automatic, to make automatic decisions based on some data into the record that comes in. An example that we have recently used is people that to write their publications, they're going to use internal data, for example. And they may already have the authorization to use that internal data for a publication, or they may not. If they have the authorization, well, you can go to next steps. There's nothing wrong with that. But if you don't have the authorization, that has to go to the data protection department for them to say, well, yes, that's okay, they can continue, or well, be careful, you cannot use that. So there you have a workflow where it's not the person that is putting the publication in that decides what the next step is. It's a condition based on the data that he or she is providing. So we have added this with automatic steps in the workflow that allows you to add all these this type of conditions and actions, and then based on those conditions, and you can say today 2 different type of actions, which are, well, I go to step X, or I send an email. Or I do both. There are 2 different. There are 2 actions today possible: changing the state or sending an email. And we foresee a 3rd one that is going to come in the future, which is going to be just call an API, an external API. For example, that will allow you to say, well, once I finish, for example, the approval of a publication, I can send the record to another system to declare that the things are done, and then maybe other systems are going to do something with that. That's how we see that can evolve in the future. But at least these automatic things are not in the one that you have. I mean, that you may have if you have downloaded the GitHub repo, but something that's coming and will be there very soon, because it's. Tests are almost finishing there. And then the other one, it's conditional pipelines, which is when I show you the pipelines, basically. You say, well, I'm going to define a pipeline for a given entity. And you can, that means that pipeline will apply every time a record comes into that entity or it's updated into the entity. And that was good at the beginning, but we have faced cases where the most classical one is in different steps of the workflow, or the approval process, you're going to have different fields that are going to become mandatory. They're not mandatory at the beginning, but some of them are going to be mandatory through the process. So you could define, what we did here is to define, well, based on some conditions, you could say which pipeline is going to apply or not to the record. So you could say, well, have a pipeline for mandatory fields of step 2 and another pipeline for mandatory fields of step 3. And then you say, well, if a step equals 2, then you apply this pipeline, and if a step equals 3, you apply this other pipeline. So those are things. I think those are the maybe the most important ones. There are some others in the changes that you may see soon being deployed in the repo. But I think these two are the most important ones in terms of the flexibility and the functionality that give you as a user and administrator of the platform. So I think that's all. I only had one more thing, which was just to show you a little bit the API. So I have just one call that is going to retrieve all the records in my entity. So this is basically the address of the API or the endpoint. This is my entity, and as I do in a search for multiple results, we add an S to say it's a plural in terms of results. So it's just a
Hey, I
get
don't hear you anymore.
Yeah, sorry, can you hear me now? Hello?
Alina, I think Alina has a problem. Alina, do you hear us? Alina is gone. I think
it's a problem with her connection.
Yes, she's coming back probably.
Okay, yes.
Because I don't see her at the moment.
So I'm almost finished. I hope she's going to come back before I finish. If not, she can ask the question. I can repeat, no problem.
And it's recorded anyway.
Okay, good. So I said I have the endpoint of the API. So this is the name of the entity, and I said I'm going to do a get just to get all the records in there. So I just click on the send request, and I should have there the results. So there are two records, and here I see all the information of those records. So you see that we had, for example, the ID and the name of the institution in the normalization, and then in the other one should be Caroline, I guess. Yeah, if all works well. So that's the way. Well, you can get, for example, everything because I have not defined any condition in the search, and I have said here I want all the fields. Another example would be I just want to get some fields. So let's say, I guess I click on the same. I just want to get some fields, for example, full name and the institution, but the name of the institution. So I say I want to get full name and denormalization institution, and still it's a get and search function. And I'm going to go here and say, it's like in the source now I only have full name and institution. I don't have all the other fields, and I will always have the ID actually. I don't have an option to say I don't want that one. Well, you can say you don't want, but we would always give you that one. So this is just a basic function of the API that I wanted to show you how it's just a basic. I mean, a standard REST API where you're going to have a get function to get one ID, or you're going to have a get with search to search multiple, where you could add also conditions. You can have the delete operation to delete one entry, and then you can have the put and post to create an update records. So you get all that when you create an entity, basically. So that finish it. I'm 3 minutes late, but hope that was useful for you. Any question?
About the REST API, it delivers the data in JSON or something like that.
Yes. Actually, format. If you want to see the row, I think I can body row here. So it's a preview or formatted, so it's a little
and
bit.
Is it your own format of JSON?
It's actually going to be. I mean, this first part, entity result and hits, it's our. But then what you see in here, or mostly in here in source, it depends on the structure that you have defined in the entity.
Okay. No.
It's going to be dependent on each entity, and then if you select some fields, as I did here, well, you're going to have only those fields in there. If you don't say anything, you're going to have all of them. But it's going to follow the same structure than your entity.
Okay.
Any other question?
Yes, I have two main questions. One of them is, do you have some documentation on how to perform bulk data loads to Polaris OS? That's the first of the questions.
Not sure we have documentation on that, but we can write a little bit to you if you want to, because the options exist in the API, so we can write that down if needed.
Okay, and another thing is if you have a way to define how the information is presented within Polaris OS, because as you may know, for instance, library systems, they have certain ways to present information to users, like catalographic records or something like that. Do you have a way to define such a structure?
Now, we use. We have one to define the bibliographic styles. Now, we have a client where we have 5 or 6, but the library we use have hundreds of bibliographic styles. So I'm not sure if that's what you are referring to. And what we do is when you're on the page of a publication, you can actually download or copy and paste. It depends on what you select, the citation form for that publication. Is that what you're looking for?
Well, I'm asking about something like, for instance, the standards views inside the library catalog. For instance, ISBD or Mark 21. So a sort of that kind of view is is it possible to create something like that within Polaris OS?
Now you have to define that there are two options. Either you build a form that presents the information the way you want to, or if you look at what I present, it was all on the back end. I didn't present anything on how to build pages on the front as the user interface, because those pages are actually developed on a case-by-case basis. So you can actually develop the pages and then put those pages into the front of Polaris OS.
Leandro, I think there is another vision, and I think where people in information science are looking at a lot at standards. Working at the library standards from Mark 21, RDA, ESBD, and such things like that, that are very important. Also for repositories and for CRI systems, things like serif in the end. To have these standards working, here I see the flexibility is the most important aspect, and it is possible probably, but I think it is important to see how the standards that are important can be easily implemented in such a flexible system. Without having to work out completely everything. I think that's a bit the challenge. One of the challenges.
Yeah, you mean by not having to build everything, every entity and every form from the scratch, but starting from something.
And not only that in the end we have to be very. If you use it, you have to be very careful to use structures that can that relate to the standards. We need to go back always to the standards, even if there is a need to a lot of flexibility. I know when you start with the repository, in the end you ask half of the formats outside of the standard. That's clear. Huh? But at the same time, if you have to deliver information to institutes, you have to do it in the standard, and it can be an extended standard, but it's based mostly on the existing standards. And that's a bit the balance to look at.
Yeah. I see what you mean, and then you have, I think, there's always two options from what I see, and it depends on how you deliver the information to the external institutions. You can build on top of the API to say, well, they're going to have direct access. Then you could build functions on top of the API that will format the information how you need to be formatted or how they need to be formatted. Or you can use the API if you deliver things like batch reports or text files or things like that. You could build on top. I mean, you can build based on the API to retrieve all the information and then format that any way you want and putting that into the resulting files that you're going to handle to the external institutions. So it depends on the use case. You would build that in Polaris OS or outside using the API.
But I understood there were, for example, if you have a repository solution, you need to have an OAI.
We have one, and you're right. And what we do is we're going to map, but we leave the users actually the option to have their own publication structure, and then we go into the OIA module and we map the entity, the publication entity, to the now the format we use, the metadata prefix we use is the OAI DC for Dublin Core. So we map the publication entity to the Dublin Core fields for the OAI PageMatch server.
From the other side, if you, for example, a lot of people have DSpace in the world, in Cuba, importing these collections in Polaris OS, is that a big issue? Are there scripts available for that, or?
Now, the first question, is that a big issue? I would answer no. We always have migration processes to do in every project. Do we have tools that exist today for this space? Not yet. Would like to, but we don't have them yet.
So that's something. No, in the end, you will probably start from a structure or the Dublin Core structure. Most of the people will have already some extended Dublin Core, not only qualified but extended too. So you have to map that to ingest in one way or another.
Yeah.
Also, if we look at the quiz aspect, there is a lot of information in databases from universities. At the moment, is there a policy to have to be able to translate that to Polaris?
You mean the policy systems have how they enter information or how they manage the information?
Yes, I mean, for example, Vivo is mostly focused on entering information in their system through ingesting larger packages of coming from repositories to Excel files to database files. Is that also a policy that can? Is that also possible in Polaris?
Now, in Polaris, there's a batch or the batch load that you can use, but you need to format the records on the specific format in Polaris OS to be uploaded, which basically comes to what you have defined in each entity.
But Manuel, if I can, you can also use the API. I mean, for example, if you would like to get the data from Crossref, it's something possible. If you want to get the data from existing repositories in the country, it's something that we possible in Polaris OS.
Yeah, I mean, it is. That's why I say at the beginning, the answer to the first question, sorry, is yes. You can migrate any type of data that you want. Now, but you need to develop using normally the APIs, either in batch or in a object by object basis.
Linking it to external authority systems, like the agrovoc vocabulary, like other vocabularies and such things like that. Is that a possibility? Like from what is it again? I forgot. The European Commission has a lot of these.
From Cordis or things like that, for example, you mean, or from existing control vocabulary lists?
Yes.
ISSN for journals, that kind of thing.
And which are available through also through REST APIs or through other endpoints. Are there possibilities on that?
Now today, we import the data into Polaris OS, and then we use the entities in Polaris OS, and then we have processes that goes periodically to the source, and then get the information back into Polaris OS. So that's the current implementation that we have for that use case.
But you have to everything, and you have to bring it all to the Elasticsearch.
Yeah, we create an entity for each control vocabulary list, and then we populate that with periodic processes.
With the structure, or simply is this more a list of terms, or can you keep the structure of such vocabularies?
You can define any structure you want. Actually, it's not. There's no limitation. To give you an example, we have some lists that are just lists of values, so you only have one field that is the title or name, or you name it. But then we also have, for example, countries, where you have the name of the country, but you also have the ISO code with 2 characters and the ISO code with 3 characters. So there's no limitations in that.
Also the relations. I mean, the broader, larger, the broader relations. What is it again? I forgot.
The parent and child.
The parent and child and such things like that. Is this also possible, or is there a graph option on that?
Now you can define that in the structure of your entity. So we have, in one case, we have defined a hierarchical structure where we have parent and child, and then we can use that, for example, to select childs only if the parent is selected or things like that. So that kind of things you could configure all that with the entity on one side, and then with the select fields on the others, saying, well, you need to select this. The options that you can use in these select fields are based on another field before.
Anybody has a question further on? Okay. I put in the chat also the link that Carolina gave us about the demos of Polaris OS in Spanish. So if people want to test it out, they can go to the different files. Faber, probably we will try to get them also on our Moodle, to have them available more easily in Cuba. Nobody has another question? I think it was a very interesting presentation. It has a lot of possibilities, and we will have to look at it in the next weeks to see what are the possibilities for the project in the first place. We have to get through this analysis, and then we surely come back to you. Manuel, Carolina, y Jan.
Perfect. Okay.
Yeah, perfect.
Thank you, Mark. Thank you, everybody.
Yeah, thanks for your time.
And of course, when you will discuss about Polaris OS, and questions will maybe rise up again. So do not hesitate to send it to us, and we for sure will answer it.
Okay. Phoebe, do you have some remarks?
No.
Okay, you're listening.
All the discussion have been very good, and also the questions and the comments.
Carolina, if you have also these demos in English.
Not yet. We are working on that, but they are not yet available.
Okay.
We have just the Spanish version.
If you have them in English, I also can show them at my institute.
Okay, perfect. We will see if we can work on it in the coming weeks.
Yes, but take your time. It's something that will take time anyway.
Okay, perfect.
Okay, then we can close the session. Thank you very much.
Thank you very much.
Thank you.
Thanks, everyone.
Thanks, everyone.
Goodbye.
Take care. Bye.
I stopped the streaming.
Bye. Take care.
Bye bye.
Bye.
Bye.